That p orbital you drew in class, the dumbbell, 2 lobes, a pinched waist in the middle, nature's actual version is a donut. The dumbbell is something we invented because it's easier to draw. And that's the smallest lie in the picture. That whole tidy chart of orbital shapes is exactly right for exactly one atom in the universe, hydrogen. Or everything else, including you, it's an approximation that just happens to work. Start with what an orbital even is. It's not a path. Electrons don't loop around the nucleus like little planets. That's the Bohr model, and it's been dead for 100 years. An orbital is a wave function, a piece of math. Square it and you get a cloud of probability. Here's where the electron is likely to be. And that cloud has no edge. It just fades out forever. So those crisp shapes with hard surfaces? We drew a line at about 90%, the space the electron sits inside most of the time, and threw the rest away. The shape is a contour we chose, not a wall. And these clean shapes only fall out of the math exactly when you have one electron around one nucleus. That's hydrogen. Strip any atom down to a single electron and it's perfect. Add a second electron and it breaks. Take the shapes first. The s orbital really is a sphere. Fine, no notes. The p orbitals are where it gets sneaky. The real, definite energy p solutions are 1 dumbbell and 2 donuts. Fat rings circling the axis. That's what actually comes out of the equation. But donuts are a pain to work with. So we blend them, add the 2, subtract the 2 into a pair of clean dumbbells pointing along x and y. Same total cloud, easier picture. Pure convenience. And those colored lobes, one red and one blue, not decoration. That's the sign of the wave, plus and minus, and it's the whole reason atoms bond at all. The fuzzy gray cloud version quietly deletes it. Now the deeper crack. Hydrogen has 1 electron. Helium has 2, and those 2 shove on each other, constantly. Add that single shove, electron pushing electron, and the equation stops having a clean answer. Not for helium, not for carbon, not for any atom but hydrogen. There's no neat formula, ever. So we cheat. We let each electron feel the others only as a Bohr average, and we hand it a hydrogen shape anyway. That move even has a name, the orbital approximation, and nearly all of chemistry runs on it. What gets thrown out is the thing electrons really do. Dodge each other, live in real time. That's called correlation. A true atom is one tangled, woven wave function, not a stack of separate orbitals. So the 2p orbital of oxygen, the phrase your textbook repeats 100 times, is, strictly, a useful fiction. Oxygen doesn't have tiny hydrogen orbitals inside it. We're just borrowing hydrogen's costume because we've got nothing exact to put in its place. Now, the one you probably trust most. Methane, 1 carbon, 4 identical hydrogen bonds, 4 matching sp3 hybrids, all the same. Clean, symmetric, and testable. Hit methane with light, knock its electrons loose, and measure the energy each one was holding. 4 identical bonds should give 1 number, 1 peak. You get 2 distinct energy levels, around 14 and 23 electron volts, in a clean 3-to-1 split. The 4 bonds really are equal, but the electrons inside them are not all sitting at the same energy. That doesn't make hybrids fake. They nail the shape of the molecule. It means the simple story. 4 identical orbitals at one level was hiding something the instrument can see and the cartoon can't. And before you say we photographed orbitals, not really. Those famous images show electron density, the cloud. The orbital itself, the wave with its plus and minus, has never been directly measured. It's an inference, a tool. So why still teach the dumbbells and the hybrids? Because each layer is the right tool for a different job. Dumbbells for how bonds point, hybrids for the shape of a molecule, the cloud for the feel of the whole atom. None of them are wrong. They're a map. And the map was never the territory. It's just clean enough to actually use. So next time you see that perfect chart of orbitals, the spheres, the dumbbells, the clover leaves, don't read it as a photo of the atom. Read it as our best sketch of something that, honestly, refuses to be drawn.